History of Probability. Introduction. The history of probability dates back to ancient civilizations, where the concept of chance was linked to dice and games of chance. Over time, the study of probability has evolved, influencing fields such as mathematics, economics, and science. The earliest recorded instance of probability dates back to the ancient Greeks and Romans. However, it was not until the 17th century that the formal mathematical theory of probability began to take shape. This presentation will delve into the fascinating journey of probability and its impact on modern society. Probability in ancient civilizations. Probability was a significant concept in ancient civilizations, with its roots traced back to Mesopotamia and Egypt. In ancient Rome, probability was associated with chance and randomness, and it was often linked to gambling and divination. The Romans used dice for gambling, employing probability concepts intuitively. In ancient India, gambling was deeply intertwined with probability, as evidenced by ancient Indian stories containing elements of chance and uncertainty. The Sumerians in Mesopotamia made substantial contributions to the development of mathematics, laying the foundation for potential applications in probability theory. Although there is limited documentation of probability, in ancient Egypt, the ancient Egyptians had a deep understanding of mathematics. In ancient China, the influence of uncertain events and probability-related ideas dates back much earlier, but the serious study of probability and statistics began in the 1930s. Probability in 16th century. In the 16th century, the concept of probability was not yet formalized as a mathematical theory. However, there were significant developments in gambling and games of chance that contributed to the understanding of probability. Italian mathematician Gerolamo Cardano, in his work Liber di Ludo e book on games of chance, discussed the rules of probability in card games and introduced the concept of calculating the probabilities of different outcomes. Although not a formal mathematical theory, these early explorations laid the groundwork for the development of probability theory in the centuries that followed. Probability in 17th century. In the 17th century, probability theory saw significant developments, particularly with the work of Blaise Pascal and Pierre de Fermat. Pascal and Fermat's correspondence on problems related to games of chance laid the groundwork for the modern theory of probability. Their work on the concept of expected value and the probability of events occurring underpins many statistical and risk assessment methods used today. This period marked a crucial turning point in the formalization and mathematical treatment of probability, setting the stage for further advancements in the field. Probability in 18th century. The 18th century marked the emergence of the mathematical treatment of dice, with the term probability having its etymological origins in medieval Latin and its mathematical sense emerging in this period. The study of probability can be traced back to ancient and medieval law of evidence, with examples such as the use of astrology in ancient games and the first dice game called hazard. Mathematicians like Jerome Cardano and Blaise Pascal made significant contributions to the development of probability theory, inspired by games of chance. Probability theory became closely allied with gaming until the Industrial Revolution, after which it began to influence fields such as gambling, insurance, quantum mechanics, and space technology. Probability in 19th century. In the 19th century, the study of probability underwent significant developments, building upon the foundations laid in the previous centuries. Mathematicians such as Laplace and Gauss made substantial contributions to the field. Pierre-Simon Laplace, a French mathematician, made pioneering advancements in probability theory, particularly with his work on Bayesian probability. He introduced the of inverse probability, which forms the basis of Bayesian statistics. Additionally, Carl Friedrich Gauss, a German mathematician, made significant contributions to the theory of errors and the normal distribution, which are fundamental concepts in probability and statistics. These advancements laid the groundwork for the further development of probability theory in the 20th century. Probability in 20th century. In the 20th century, probability theory experienced significant developments, particularly in the context of physics and mathematics. Physics made a groundbreaking discovery with the probabilistic nature of atomic scale phenomena in quantum mechanics. Moreover, the 20th century witnessed a shift towards generalization and abstraction in mathematics, with an emphasis on logical concepts like consistency and completeness. This era also saw the rise of specialized fields and areas of study in mathematics, with notable contributions from mathematicians such as G. H. Hardy, Srinivasa Ramanujan, and David Hilbert. Additionally, Kurt Gödel's incompleteness theorem challenged traditional mathematical thinking, paving the way for the development of computers and artificial intelligence. Probability in 21st century. In the 21st century, probability theory has seen significant advancements that have reshaped various fields, including mathematics, physics, and statistics. The growing recognition and acceptance of probabilistic methods in mathematics have led to increased rigor and new applications. These methods have been successful in analytical number theory, contributing to significant breakthroughs in results such as Van der Waals and Semiradis theorems. Additionally, probability theory has played a crucial role in statistical physics, with notable breakthroughs in areas like combinatorics and statistical physics. Furthermore, developments in physics have emphasized the unity of physics with astrophysics and cosmology, involving concepts such as quantum entanglement and gravitational radiation. Probability theory has become a foundational tool in scientific and practical applications, solidifying its importance in modern research and technology. Potential uses of probability in future. The potential uses of probability in the future are vast and diverse, spanning various industries and fields. As probability theory continues to evolve and expand, it is expected to play a crucial role in shaping the future in the following ways. 1. Genetics. Probability will be instrumental in understanding genetic inheritance, gene expression, and the likelihood of certain traits or diseases being passed on from one generation to the next. 2. Weather forecasting. In the future, probability will continue to be a cornerstone of weather prediction, helping meteorologists and climatologists assess the likelihood of specific weather patterns and natural disasters occurring. 3. Risk management. probability will be increasingly utilized in assessing and quantifying risks in various sectors such as finance, insurance, and healthcare, aiding in making informed decisions to mitigate potential losses or adverse outcomes. For finance, probability will play a key role in financial modeling, risk assessment, and investment strategies, enabling better decision-making and allocation of resources. 5. Sports. Probability will continue to be a valuable tool in analyzing sports data, predicting outcomes, and optimizing strategies for competitive advantage. 6. Artificial intelligence. Probability will be integral to the development of advanced AI algorithms, particularly in the realm of machine learning and predictive analytics, enabling AI systems to make more accurate and reliable predictions based on probabilistic models. Thank you.